Hey guys, I'm going to be starting something new. Here on this channel, I'm going to be introducing some coding as well because I'm a grad student in physics, and in physics, what you need to know a lot of is coding. There's usually so here's how it goes. In physics, you have the theoretical stream, you have a theoretical is just what you think it is. I mean, you'll have a whiteboard and you'll be sitting in your office and you'll be working out some theorem or using some theorem and some approximations to construct an abstract view of the universe, depending on what your field is, of course. An experimental physicist might run a bunch of experiments to test a theory out or to review a paper or something. And a computational physicist is kind of in between. A computational physicist is someone who is a theorist in a way, but analyzes using simulations, and a lot of it might be to verify experimental data, refine computational models, mathematical models. And a lot of my work, which is on analyzing the dosimetry around a gold nanoparticle, has to do with C++ primarily, because I use Monte Carlo software, as well as, and it's open source software, as well as some Python, because I know a lot of Python. I've used Python since I was, like 20 years of age. So Python is huge in what I do. I don't know a lot of the jargon, so I can't really, I don't know Python from a, perspective of, making games or anything like that. But the purpose of this channel, I guess, is to, the application of Python towards the sciences. That's kind of what I'm aiming for. In this specific video, I'm going to just be introducing a mathematical function, how to print, and what I used when I was starting off with Python was I used the text editor idle, and idle is not. I mean, I remember I was in a graduate level course in physics, and I mentioned that I was using idle, and everyone there who was like, they were so much better than me in the use of Python towards mathematical sciences. They were laughing. It's idle is a laughable text editor from what I hear, but I mean, now what I do is I just use Vim. I use Linux. I'm on a Windows computer right now, but I use Linux regularly with a command line, and you run the editing in Vim, and then I just hit Python and then the file name, and it runs. And what I like about idle, though, is that you have the run module, and you got a Python shell that gives you the output right away, so it's kind of neat. So for beginners, I'm on Python 3.5.4, and it gives you idle readily with the installation, so check it out. And I'll leave a link in the description if that helps. And this is just a very, very basic first video. Here what I have is the very first statement. What you need is modules. And in these modules, you have certain objects or functions that you will be using. So in this case, I have imported the math module. And in math, there is a function called square root, right? So to even use that function, what I have to do is I put the module name dot the function name. So here I have math dot square root, SQRT. And what I've done here is I've defined a function. And so you literally put def and then whatever you want to call the function name. And it is good practice to put a word, put a name that makes sense. So in this case, if I'm doing grade 10, grade 11 math, and I'm calculating the hypotenuse multiple times, grade 9 math, I guess, multiple times, I would much rather create a program that could just, because if I'm doing, I remember I was getting like 50 to 100 questions of literally just calculating the hypotenuse. And it's like so freaking annoying, right? Like, and if the teacher's not checking it, why am I doing it, right? So I would create a function to calculate the hypotenuse. And in this case, what I do is I say define hypotenuse, okay? And that's just a name. I could call it whatever I want. I could call it Batman, right? Doesn't matter. And then I put brackets, and inside the brackets, these are what are called the arguments, right? The inputs. And you have to put, remember this, so after you put the inputs, put a bracket, curly, not curly, is that curly? See, I'm like totally out of it. It's like 2 o'clock in the morning right now. Put a bracket, and then put a colon, and then you gotta put whatever you want in the body, right? I don't need much in this function. All I need is to return a specific statement that I know, and it's math.square root, so it's the square root, and then in the brackets it tells me what I have to square root, and it's basically the inputs squared and added together, right? That's essentially what the formula for the hypotenuse is, right? Pythagorean theorem. C squared equals a squared plus b squared to get c square root. And then what all I want is to print, right? That's legitimately what I want to do. And to test it out, what I write is something very readable and easy to read, right? Easy to understand. So in this case, I have the hypotenuse is, and I put a comma, and then I put the actual value, right? So you put like a string, and this string is just a set of words to make the output more readable and understandable. Because if I just had the number, and this you'll find with larger programs, this is like what, 4 lines of code. With larger programs with multiple output statements, it gets really complicated. So what you want to do is you want to put some strings together, some words together in order to make it easier to read, so that you know where you are in the code, right? When it outputs. So here I put hypotenuse, return hypotenuse with A being 4 and B being 3, right? And then I hit run, and I get the hypotenuse is 5. Now, if you just to test out the code to see if it's working, if you run that in your head, 4 squared is 16, 3 squared is 9, add those together, you get 25, square root of that is 5, it works, right? Now, notice I've put floats. I don't think it matters if I put floats. Floats are basically decimal numbers. But if I put integers, does that change anything? I don't know. No, it doesn't really change anything because I'm squaring, so it doesn't really matter. Sometimes it does matter, and I guess I'll get to that in a different video. If you're, I guess this video is, the specific video is to help you like run through your math homework much quicker. Like, you shouldn't be taking hours on your math homework, especially if you get the concept. If you get the concept that it's square root of a squared plus b squared, then what the hell are you doing like 50 questions, right? So yeah, that's the print statement. Now let's say you had to do, this is just one input, right? What if you had to do this multiple times? So what if you had to do this 10 times? And so let's say you had A being an array of like 4, 3, 2, and that's it. And then B is 3, 2, and 1, right? Could I devise like a program where I can print all of the combinations of these guys together, and so that I can finish my homework in one shot? There is a way. And what you can do is you can go, okay, and I'm not going to do all the combinations, but I'm going to do like the first element of A, first element of B, second element of A with the second element of B, and calculate it that way. So there's a way, and it's called defining a for loop or creating a for loop. And what you can do is you can go for the index, I'm just going to call it index. Index is a dummy variable that you use, and it's very temporary, and it runs through an array, right? So I'll show you how that works. So for index in len of, and len, what that means is length of a. So what that means is for index in len of, or range of len of a, okay, what I want to do is I merely want to do this statement over all, or run this statement over all values. Okay. Okay, so what I've done here is I've said, okay, I'm going to change my index, okay? And it's going to go, so that index right now is going to go between 0, 1, and 2. 0 just means the first value, 1 means the second, and 2 means the third. I know that's counterintuitive, but in Python, it goes from 0 and onward, right? Whereas in MATLAB, it goes 1, 2, 3. It's more intuitive that way, MATLAB and Octave. So index is just a number that is being inputted. So what that means is it'll print the hypotenuse for the first value of A, the first value of B. So it'll take the hypotenuse and print it. Then it'll do the second value of A and the second value of B. And it'll print it. And then it'll do the third value of A and the third value of B. And it'll print it, and then you get your results. And you're done. Now, what is this range? Range is basically an interval of numbers, right? So if I don't define anything, if I just give it a length, what is the length of A? The length of A is 3. So range of 3 just means give me 3 numbers, right? 0, 1, and 2, and run through all those numbers and give me a certain output. That's all I'm doing here. So let's see if this works. Hopefully it doesn't give me any errors. Okay, so oops, let me delete that first. Let me comment out. This is another aspect of coding, commenting out. So I'm killing a lot of 2 birds with 1 stone, multiple birds with a few stones, I guess. So I'm commenting out the first statement because the first statement printed out. Let me just do that so that, let me run it again. I should only get 3 blue statements. Okay, so what I've done here, I've got the hypotenuse is 5. That's my first combo that I already knew, right? And the second value is the second combination, 3.6, and it's given me to, I think, 16 digits, which is standard. And the third value is 2.24 to the 100th place, right? So this is a neat little program that I've used, and if I, and this doesn't just apply to the hypotenuse. You could apply it to any function, right? Any function that you want, no matter how complicated. You could apply it to integrals if you're in first year or second year university or grade 12. Like, I don't think you integrate in grade 12. Anyway, you could apply it to calculating derivatives. There's a neat little way of doing that. You could apply it to grade 11 mathematics if you're doing sine law. You could apply it to, what we see here, the hypotenuse in grade 9. You could apply it to solving quadratic equation, like using quadratic formula. That's probably the most annoying one. I should probably have devoted a whole video to just solving the quadratic formula using coding, where you can literally just input A, B, C. Maybe I'll leave that for another video. That would be fun. So that was probably the most annoying one. But the hypotenuse is, I guess, just a simple example. So here we've talked about importing. We've talked about defining a function. We've talked about using a for loop, creating a for loop. We've talked about print statements all in one shot. So I hope that was helpful. Share this video if you know of anybody who's struggling with time management of homework. Learning to code this way to produce results really quickly is not only beneficial but very, very, very it helps you focus on what's really important in life and in other aspects of your homework, right? So like maybe you have some assignment that actually matters a lot, and doing hundreds of questions of the same old crap doesn't really help, right? Just one tip that I have, I hope I'm not rambling on, but just one added tip: if you are doing your homework and you have 20 or so questions to do, okay, and it might not be as hard as calculating the hypotenuse. Can be completely easy, like so easy. What you want to do is you want to avoid doing the easy questions first. Okay, so you might have, I don't know, question 1 till 20, right? You do not want to do question 1 A, B, C, D all the way through F, and then question 2 A, B, C. Do not do them chronologically like that. Instead, what I'd recommend is you would do the most difficult questions first. Start at 20 and go down. And even then, if there are multiple parts to 20, like if 20 is A, B, C all the way through J, do not do A, B, C, D all the way through J. Do the last 3. Do maybe A, C, E, like skip, right? Especially if your teacher's not marking it, right? That's the most crucial aspect. Are they marking it? If they are, and you're given so many questions, I would say, rebel a little bit and don't do them anyway, because that's a lot of questions. And it gets to a point where if you're doing way too many questions, you actually miss the main concepts. I find, like, I would miss a lot of the main concepts by doing so many questions. But if I did a few that were the hardest, I get the concept, and it's logical to say that if you can do the hardest question, you can probably do the easiest ones, right? And usually also, what I find a lot of students have issues with, have issues with word problems. Word problems are number one, right? So typically, if you look at any standard mathematics textbook from grade 9 till 12, even into university level, like calculus level, first year, second year courses, you will find a lot of them have standard A, B, C, D all the way through for the first maybe 10 questions, and then after that you've got like word problems. So do those word problems first. If you can understand them, then you're pretty much good, and just do a few of those easier ones. And if you can, if there are a lot of them and your teacher's marking it, try coding, right? Try coding in the answers so that you don't take so long on them and you can focus more on your other homework, or just relax a bit, So hopefully that was helpful. I'm going to keep doing more coding, learning in Python. Then I might switch over to C++, which is what I'm currently doing, C, as well as maybe some Java. I might even start tutoring JavaScript, who knows. But I hope that was helpful. So subscribe, like, comment, share, do whatever you gotta do. We appreciate the support, and I do a lot. So thank you so much. Have a good one.